don't know, man. It hardly clicks half the time.
Guys, I'll give you another minute here on the warm-up.
Oh, like
2 minutes, sure.
Maybe like 4 minutes.
4 minutes. Bargaining.
bargaining.
No, not 8.
25.
Cutting you off there. We'll say a few more minutes.
It goes up, you multiply it by 2, so you multiply it, it goes to 0, it stays at. So this one here, okay, so you move it to here, right? You move it to here, then you multiply by 2.
Okay.
So it goes
This
to
is it. This is plus 1.
So it goes to
That's 1/2, right? Or even if you factor it out, it's still 1.
So this goes here, very right, and then times 2, so it goes to here.
Oh my god, I'm stupid.
So this
No,
is
you're not.
actually.
You're not stupid. Oh, okay.
You just didn't get it until now.
No. I literally did it on the last one, and then I just didn't do it on this one.
You know.
Yeah, consistency. Yeah. It's actually, like, yeah, it's bad. Oh, I felt that. Okay, no, I still messed something up.
I think they're talking about.
No, oh, wait, I'm fine.
Question?
I'm great.
I think I remember. Oh, yeah. No, like. Yeah.
So it comes from the unit circle. Yeah, so like at 0 radians, sine is 0. At pi over 2 radians, sine is 1. At pi radians, sine is 0. 3 pi over 2, yeah. Because the x-axis is the radian. And then evaluating the sine or cosine gives you the 1. Okay.
3 pi over 1/2 times, and you gotta reverse it. It's not easy. The job, so. That's why.
Yeah.
You had it right. I know, but it looks what? Okay.
I forgot. I forgot about that period portion.
Yeah, that is a key piece.
Yeah, I forgot how to find it, so I just like shoved whatever was in the bracket.
Okay. I mean,
Yeah. Oh, you're right. I don't know how to remember that though. Like, how do you?
the period?
Yeah, like how do you remember how to find it?
I'll go right here in a second.
I got the points right at least.
Are we getting close, guys?
Yeah.
Okay. Super confident.
Yeah. When is the unit test still like next week? Because it was like, I remember it was like December.
Wednesday, yeah. December 7th.
We're still on board for that. We're still like
Yeah.
paced stuff, really?
Yeah. Because we're graphing all these today, and then Thursday is kind of a little bit of everything. There's some graphing, but also like writing equations of the graphs, like going in reverse, and then a review day. and then skill 5 assessment.
We haven't done any quizzes though.
Yeah, we don't really quiz.
No one's at first unit.
But we going straight to the cumulative?
Yes, next week.
No, not the cumulative, just the skill 5 assessment, attempt 1.
Oh my god.
That's
I
what's
thought
coming up.
I thought it was a unit test. I was like,
We've like renamed everything, and now it's like, wait, what are we saying?
Whenever people say assessment, it always meant like a straight
Big
test, and
thing.
people are like, I don't know what you're talking
Is
about.
it the skill 5? Isn't that still a test?
Okay.
It is.
So it's quiz.
It is. But it'll get replaced. It's more of like a formal checkpoint. Yes.
Thanks.
So like you don't want to ignore it because,
Well,
Yeah.
but it's like a low pressure kind of test, if that makes sense.
sounds like filming it.
It's hard.
Let's look at that test.
It is also just skill 5 on that day because we don't have any like
We've been on my prior one.
prior things.
It's also the day my history thing is due.
Ooh, lots of people decide.
Happy that I haven't started.
Wait, is that a push or two?
Oh no, the project.
Like literally, I didn't know what to do, but I just like kind of started with the search. Not bad. Just start with the one. Because
Oh, I think Eric is there.
Out.
out.
Are they out? Yeah.
But I will
Thank you. No.
Oh,
Okay. But he made it a group project and then proceeded to make it. If you were in a group, you had to do double the work.
Yeah, I just kind of no,
Because like at that point, I'm just doing half the work and doing a normal project. Now, why am I working with a partner?
some things at doubles, but some just don't. You're at negative 3.
Like he made everything. He made everything double. He said everything is double. Like if you we have like 2 local portions.
I have to do 3, like regardless.
3.
All right, guys, should I start?
No, just like.
Okay. I'm glad you want to finish.
Oh no, he didn't actually
You didn't
specify.
say.
Oh, no. Oh,
Give him 0 instructions. He doesn't know what he's doing.
It's his first year, right?
It is his first year. I wonder how long we're about. He likes to spend a very long time in college basketball, so I wonder how long it's been. I have like that. That's just my class. Yeah.
Well, yeah.
Also, Jeff had a reading quiz and I didn't do the reading.
Oh my gosh, why is it like I hate readings. Why can't we do it more like just case?
Exactly. Thank you. The readings are boring. I'm not engaged in case studies. No, that's engaging. That's cool.
All right, guys, let's see how you did. Okay, so on the first one, what is the period of this graph? Pi. How do we know that? 2 pi over b. So, and b is this guy right in here. That's b, okay? So if you're struggling with how to label the x-axis, take the original labels, the pi over 2, pi, 3 pi over 2, and 2 pi, and just divide them by whatever the b value is. So we know the last one's going to be pi. The second one was 3 pi over 2. If I divide that by 2, it becomes 3 pi over 4. Pi becomes pi over 2, and pi over 2 becomes pi over 4. Squeeze them in over here. I know those are small. Okay, so that's what you're doing with the x-axis. Always just divide by whatever the b value is. Okay, I'm going to do parent graph of sine, but with the vertical stretch by 2. Like I can do that all in one step. So sine always starts at 0, 0. The next tick mark, I'm going to go up to 2 this time. back to 0, -2, 0. Are you guys getting better at like following the pattern? It's like middle, low, middle, high, middle, low, middle, high, middle, low. Just keep going.
The original graph?
That is sine stretched vertically by 2.
Oh,
Okay?
oh, okay.
All right. Then the only thing I have left is my shifting. Where am I going?
Oh, wait, sorry.
Oh,
Oh, that's the original?
oh, we're getting there. We're
That's
getting
the original stretched by 2. That's all. That's not my final answer.
Move
Original
shift to the
shift
left.
was theory.
Wait, no, up one.
Up 1 and right pi over 2, right? That's what I have to do for my shifting. How far is pi over 2? 2 takes marks. So since I'm going right, guys, I start on the left side so that I have somewhere to go. So I take this dot, I move it over to up 1.
Yeah, okay.
Over to up 1.
I scared myself.
And eventually you can just see the pattern. Okay, don't keep going off the end of your graph, guys. Stop when we get to pi, and then go back and fill in the left side. Just follow the pattern. You know the two ends should match. So I'm gonna be down here and at 1.
That's so true. They really don't work. Like the mini ones don't. But like,
Yeah? Good stuff, guys. We got it.
I
feel like it's just
Yeah, don't give me that.
that's so true.
All right, guys. Second one. What is the period of number 2?
4 pi.
4 pi. That one's easy to label, right? We like that.
Is it necessary that we label?
Yes. Crucial. Because that's how we're showing that the period has changed. So, yes. And that way you know how far a shift is. Like. All right, so I'm going to do -3 cosine. That's what I'm going to plot first. So instead of starting up at 1, where cosine normally starts, I'm going to start at -3. 0, +3, 0. Are you guys okay with me doing that stretch in the first step? Stretch and flip.
So,
We're good.
Okay, -3 has been taken care of. That's what I started with that.
yeah.
All right, then I just have the shift. It's only one shift this time. Where am I going?
You could just
Left by pi. How far is pi? 1/6. Again, since I'm going left, I'll start on the right.
I don't know how I managed it.
Make sure your ends match.
So it's really
There we go.
Yeah, Mr. Lee.
Yeah, how we doing, guys? Hey, not good. Oh no, what went wrong? The period stuff? So definitely label the x-axis first. You get why it's 4 pi. Like, are you okay with why it's labeled the way it is? So remember, okay, probably don't want. Original ones, like when we did parent graphs, were these, right? Okay. Whatever the b value is, literally just take each of these and divide it by the b value, and that's how you get your new labels. So if we're dividing by a half, you're multiplying each of them. Does that help? Okay. All right, back to it. Any other questions on the graph?
Do we get anything together?
Good job.
It was worth a try.
Go team.
This is not a team
Okay, not a team sport. That's good to know. All right, anybody need more time with these? I think we'll be formatting.
That is
Respectful.
What?
terrible. It's a nightmare.
Oh, that was. I was like, did it fall down? I know it is.
Should have pulled Star Wars. Oh my god.
That's okay. Those are the notes you're gonna take. All right, guys, note time.
Let's just stop it.
Let's just move forward ahead.
No, my
Not the captain.
And the West team in Africa now that Mon is we got put in another group of people involved. He's injured.
Okay, guys, we're gonna start today with graphing
Wow.
y equals cosecant of x. Not so sure about that?
Is it the same as sine?
It is. It 100% is going to be easier than you think it is.
Is it just sine? It should be sine.
He doesn't have to use a circle.
You can graph sine, you can graph cosecant.
I
All right.
barely graph sine.
Oh. Okay, guys, cosecant is related to sine, right?
Oh my god.
We'll do, I don't know what
I see what's happening.
I'm going to graph sine in red. And guys, we'll do normal labels here. My graph seems really large.
It's supposed to be large.
I don't know. It just is. Okay.
Yes, that was so nice.
I'm going to go 2 tick marks. I'm leading you through this. All right, and then again, I'm doing it in red. I'm just going to graph the sine function, the parent graph for sine. Hopefully this much we know, right?
I think you have too much space.
You know the
Yeah,
parent
yeah,
graph of sine, you can do it. There's just so much like groaning this morning. You guys are funny to me.
I'm glad you find this torture.
Someone's got it, please.
That was the like saddest we love math ever.
No, actually,
It's a good question.
I like
yeah.
okay.
I'm tripping on magic.
Tripling.
Physics.
Okay,
I
guys.
was like, what's
Turn this graph into your cosecant graph. Guys, remember cosecant is just the reciprocal of sine. So let's look at a couple of points here. Sine equals 1 at pi over 2, right? What is the reciprocal of 1? Don't overthink this, guys. The reciprocal of 1? 1.
You're so right.
Oh,
You got like 3 different answers there, none of them were correct.
1. Guys, reciprocal of 1. If you take 1 and flip it, what is it?
It's still 1.
It is still 1. Okay, so the dots where it's 1, your cosecant graph is also 1.
Wait, hold on, hold on. Pause. One more
I
time.
plotted 2 dots, guys.
No, one more time. I'm being genuinely serious. Please explain that again.
Okay, what is the reciprocal of 1?
One.
Oh, we're talking about just
Okay, so where sine equals 1, right? Sine of pi over 2, you don't have to write this down, is 1. What is the cosecant of pi over 2?
Oh, we're talking about y.
1.
Like, we're talking about, okay,
Y.
thought you meant x. I was like, where? Okay, alright, there we go.
Okay, what if, I'm scared to ask this, because what's the reciprocal of negative 1?
Negative 1.
No!
No, I swear I was trying to say -1, like my grade was
So those points also overlap. The negative ones are still -1. Okay, the tricky one. What's the reciprocal of 0? Undefined. You guys can do that, but you can't tell me the reciprocal of what? Okay. So, anywhere that sine is equal to 1, or I'm sorry, 0, your cosecant graph is going to have an asymptote.
Every time.
I am.
Man, that's a lot. That's too much to remember. No. How many
What is the problem?
Are we gonna have to define that every time? Like,
Draw them.
No,
I
no, I
mean,
mean,
that
like-
wasn't that bad.
no, but I mean like,
Wait, is that
because like,
it?
No, then we have to draw the shape of cosecant. Guys, I'm not going to make you plot, like, points for that. What happens, if you think about it, the reciprocal, the shape kind of looks like a parabola. Wherever the sine graph has, like, this, you know, like, mountain shape going, you're going to go this direction.
That's so cute.
That's the reciprocal.
It goes away from the sine graph. It's never going to, like, cross through
That's
your
just how
sine
it
graph.
is. You know?
Yeah, we could plug in, like, at, let's see, at pi over 6, sine is 1/2, right? So cosecant is 2.
Yeah.
Okay. But I'm not going to make you plot all of this.
So that's just how it is.
That is the shape. Yes.
will you give us like that chart you did for the last unit, and we like fill out where all the asymptotes are, and like where all the, like that again? Okay, that's what I was worried about.
I mean, math space might ask you a couple things about, like, filling and stuff, but the paper part of it.
I'll think
Okay, guys. We have to write the domain and range of this.
There's gonna be a lot of breaks.
Domain is weird, but once I show you, it's not that bad. All right, we have to use set notation here. Weird squiggle bracket x such that x is an element of the reals, but x cannot equal. Okay, guys, what it cannot equal are the asymptotes. So tell me where one asymptote is.
-2 pi.
You could say -2 pi, -pi, 0 pi, 2. Any of those.
Wait, pi over 2, pi, 1.
So there's an infinite number of asymptotes. So we're saying it can't equal pi
Oh, that's an x.
plus or minus. Guys, how far apart are the asymptotes? Pi, right? They're pi apart, so plus or minus pi k. That pi looks weird.
Why the
Okay, jot it down and then let me explain.
That is a pi k.
It is a pi k. Yes.
This is how you wrote the name last time, right?
Mr. Lake, we deserve something.
Okay, because I was
You
like,
deserve some pie for all of this.
oh, how
Yes,
we
we
used to write it.
should. Yes, we should.
We can get on the sale pie.
Leftover pie.
Here.
March 14th,
Oh,
3.14. I do not know if that is a red day, black day, or non-school day.
I'm gonna say this event is not gonna be celebrating pi. What?
What? Okay, so when you write the domain, this part, x, such that x is an element of the reals, x cannot equal, that part will be the same every single time. Okay, you just have to figure out where is an asymptote and how far apart are the asymptotes. Those are the only two things you find. The k means it repeats. A k technically represents integers, so this happens pi plus 1 pi, pi plus 2 pi, pi plus 3 pi. Like they keep occurring every pi. That's what that notation means.
Will that always be K?
It will always be k. So you replace those two things every time and that's it. All the rest of it is exactly the same. Okay.
So you never have to put a variable.
How do you know, like, you chose pi, not pi k, I guess not pi, but like, it's not equal to pi. Like, couldn't you have chosen like 0?
Oh, absolutely.
You choose any of them?
Anywhere there's an asymptote, and then how far apart are the asymptotes? Mhm.
How do you know the value next to k?
The value next to k. So just look how far apart, like how far is it from this asymptote to this asymptote? There you go. That's all it is. It's much easier than it looks. It looks terrifying.
Does it always start with pi?
It starts with wherever your asymptote is. So you could have written this one as 0 plus or minus pi k, 2 pi plus or minus pi k. Like, it depends on where they are. So when we graph secant, we'll be in a slightly different position.
Yeah, you're not gonna make us do that, though. You're nice.
It would actually be really mean of me to not have you graph secant today. And then just be like, here, good luck. All right, we're going to write the range as well. Okay, so again, we're doing the range of just the blue graph up here. So what's the lowest it goes? We can do interval notation now in this one.
Negative?
Negative infinity up to? No.
Oh,
What's the gap?
Negative 1, bracket, union, bracket, 1 to infinity. The 1 and negative 1 are included. Okay, those are a part of the graph. And then the period, guys, it's related to sine, so it has the same period. It's the 2 pi over b.
Yeah. Just the actual. Yeah.
Question.
I think you could go off the rails. Saying like this is it, it's all you know.
When you graph ones that have like period change, shift, all of that stuff, do it all as sine. And then at the very end, draw your cosecant.
Oh, okay.
So no, it's not. It's like one more step than what you were doing last time.
So you just said to graph it as sine, but if it's given to you in cosecant form, like how do you?
We'll do one here in a minute. We're gonna do the 2 parent graphs and then we'll graph. Parent graph, like cosecant, secant. All right, let's try secant, guys.
Oh.
All right, you guys are gonna try this one. I do not mean fail. I mean try and succeed. High expectations.
Really?
So what do you think you should graph first for this one? Cosine. I'll give you guys a minute to try and then I'll put it up here. You're just like, I'm waiting. Okay. Check in with your neighbor when you're ready. Do you agree?
Yeah, see, that's the audio. How's it going? Chat is audio going
Yes.
It's so just like
Well, I mean, shifted, right? Your asymptotes aren't in the same spot.
Oh, yeah. But it's like the same thing, like when it's one, it's one.
Yeah, exactly. All right, guys, when you're ready, you can look up here.
So, does it have to be just five?
Not just long.
Do we have to go? I have to use command.
Yeah, because, I mean, well, we're stopping at like -2 pi, 2 pi. Did you draw full U's?
I didn't draw anything there.
Oh, draw the half U's. Okay. Because otherwise you technically aren't graphing 2 full periods. You're graphing like 1.5.
Joy.
I know it looks weird with a little half U thingies on the ends, but that's where it ends, at 2 pi and -2 pi. Some of you are doing it already, but write the domain for me once you have your graph. Yes.
We always just write 2 pi over
So for sine, cosine, secant, and cosecant, yes. Tangent and cotangent have a different period, which is so easy to mess up. I'll show you. We're not there just yet. All right, guys, do you have the domain written? Not yet? Okay. I mean, it's years of practice. No, I'm kidding.
It's a
I
part
don't
of
know.
I like cotangent.
Someone asked me once, they're like, do you like learn that in college? I was like, I don't know.
You go to college to learn brackets.
Yeah, that whole class on bracket writing. No.
For the graph part, how do you draw like that?
So just do like the half of the parabola. It's not a parabola, but you know what I mean. Like it stops essentially at the bottom. All right. Domain. Okay. Two more paragraphs to go.
Paragraphs?
Parent graphs.
Parent graphs. I heard paragraphs. I was like,
Paragraph.
what is one?
So for the domain, it doesn't matter which aspect you use.
Oh. All right, guys. Domain. I'm going to write it up here. Check when you're ready. I'm going to pick pi over 2 for my asymptote, but you certainly do not have to do that. See, it's not as bad as it looks.
It's pretty bad.
And then your range is going to be the same as it was for cosecant.
What is missing?
It's honestly worse than right.
Pi k.
It looks like an evil listen.
It does. A table in a weird chair. It's pi k.
So it's the same as last.
Yeah. Well, I mean, the asymptote's in a different spot, so the pi over 2 is different. But how far apart they are is the same as it was. Because up here it was pi plus or minus pi k. Here it's pi over 2. Yeah, you can pick any of them, but I usually go the first positive one. All right, guys, questions on cosecant and secant?
Why do we need to know this?
Because you signed up for a course that leads you to calculus. Okay.
And okay.
Yay! All right.
Great.
When we were like,
Oh, we're finally a tangent.
Yes, we're gonna learn tangent.
Learn cosine right after that. The nightmare never ends.
Come on, guys.
This is scary, Miley.
This is scary. All right, guys. Not normal labels here. That's just because it comes from your unit circle values. That's just
It's not a normal
showing you things. All right, we're gonna make a little table over here. Well, like a baby table.
Tables never go well. Remember we had to make tables? We had to like fill out the entire table and then graph all the points on the table.
Okay. Y equals tangent of x. Remember, x is the angle we're talking about, like pi over 2, pi over 4, pi, that sort of thing. That's x. And then y is the actual tangent of that angle. Okay? So let's start with an angle of 0. So we're over here on this little unit circle. My ordered pair is 1, 0. What is the tangent at 0? Zero. It's y over x, remember? Evaluating those trig functions. Y over x. 0 divided by 1 is 0. Okay. All right. I'm not going to jump all the way up to pi over 2. I'm going to actually go to pi over 4. So if pi over 4 is the angle, what is the tangent of pi over 4?
Oh, but tangent. We heard the little
You had like little shortcuts.
like 2 or
1.
Yeah.
something.
I see. Oh my god.
This is all I'm brain for.
Then I'm going to come up to pi over 2. Remember I said you needed to know the circle? I was not kidding. Okay. That one is undefined. Good job. Just 2 more, guys. We're going to do 3 pi over 4. What do you think the tangent at 3 pi over 4 is? -1. Good job. And our last one is pi. What's the tangent at pi? 0 again. -0. -0. All right. So we're going to label out to pi this time. We're going to use pi over 4, pi over 2, 3 pi over 4, and pi. Because the period of tangent is pi over b, not 2 pi over b. It repeats every pi. Whereas sine and cosine, secant and cosecant, it took 2 pi before it would start repeating. Because that would be root 2 over 2 over root 2 over 2. Yes. So I'm going to label this first tick mark pi over 4, pi over 2. Yep.
Why does it repeat every pi?
That's just how the tangent values are set up with the y over x. They just repeat more quickly. Yep.
So when you do the period, you do equals pi over b.
Pi over b. Yep.
Okay, thank you.
All right, so we label the x-axis. And now I'm going to plot those points from our table. Okay? So I had 0, 0. I had pi over 4, 1. Pi over 2 was undefined, so what does that look like? Okay. 3 pi over 4 was -1. And pi was 0. Now that doesn't look like a whole lot yet, and we still have to figure out the left side of the graph. We got 4 dots and an asymptote so far. So let's think about what's happening over here. If I go -pi over 4, that puts me in the 4th quadrant. What is tangent at -pi over 4? -1. So that's... what do you mean switch? Kind of, yeah, because tangent is an odd function. So. What do you think happens at -pi over 2? That's an asymptote, yep. What about -3 pi over 4? 1. And -pi? 0. Okay, so the shape of it, guys, it looks a lot like your cubic function. And we get like half of it on the end here. Okay. I just thought about going backwards around my circle. So like -pi over 4 is the 4th quadrant.
What?
And then -pi over 2 would be down at the bottom.
How did that become? What?
Magic. The squiggles? That's the shape the tangent is. We could plot like points in between decimal values, but it's not real fun to do, so.
What in the world?
Are you good with all the dots and asymptotes?
Okay, yeah. Just like I wrote down.
Oh yeah, that happens a lot in here. Like if you look away from the board and the back some days you're like, what did I miss? Yeah. A prolonged look down at your paper is usually a bad thing. So.
How do you draw the arrow?
The arrow things?
Yeah, like once you got the points, you just like.
I just like drew. I don't know. They look sort of like a cubic function.
Okay.
Just do it.
Just draw.
Follow your heart.
All right. We do have to say domain, range, and we're going to write down the period. Okay, domain. You can do it, guys.
Is it the same form as the other one?
Yes. X such that X is an element of the reals. But X cannot equal what, guys?
Not equal pi over 2 plus or minus pi k.
Beautiful. The range we like on this one. Yep. -infinity to infinity. Okay, and the period. Take note of this one. Pi over b. I promise you at some point you will forget that. Pi over b. How far is it from -pi over 2 to +pi over 2? Because that's how far apart the asymptotes are. Yeah. So, and that's, you see a full cycle of the graph in that 1 pi. Okay.
Oh my god.
All right, guys, any questions on tangent? So, why? If you look, would you agree that in here you see the entire graph? Like, doesn't it start with P? Okay. And that is a distance of pi. So the period is pi. Because it takes pi to see it all. Sine, cosine, it doesn't happen to pi before you see it.
There's a million.
Okay.
Yeah,
So how far, well first, do you agree that from here to here, asymptote to asymptote shows you the entire? And how far is that? 1 pi.
I love like graphics.
Yep.
Which is
Okay, guess what we get to do next?
Cotangent.
Cotangent. I want you to try it.
How do you even back?
I think we should take
Yeah,
a
reverse
32-minute
it.
break.
Nope. Ready, go.
Not even 31 minutes. Yeah, not even like 30 minutes.
Not even like 30 seconds.
Wait, really? Like you could take
Nope. You got it. All right, guys. Try it for me. Go through it the same way we did tangent. Remember, cotangent is x over y.
Oh.
No.
And again, use pi over 4, pi over 2, 3 pi over 4, and pi. Nope. We'll get to that when we do inverses.
No.
It is.
Not for a while.
Okay. Is our period the same though?
Yeah, period. So tangent and cotangent both have a period of pi over 2.
Yeah. That's what I did. You just look at the graph.
Technically 3. Guys, I'm going to graph it up here, but don't look till you're ready. Try writing the donut. I find this shape harder to draw. I don't know. Yeah, like my brain struggles. Aiden, do you see how there's 3? Yeah. Okay.
That's your hand. Yeah. It's like
How we doing, guys?
Great, yeah.
Yeah, so tangent and cotangent are reflections of each other with a shift. When we get to writing the equations of them, that will matter, because I'll be like, write it as a tangent and as a cotangent. So you'll, not today, guys, don't worry.
funny joke.
Funny joke.
So at least it looks like one, Nice. The turkeys are good.
I'm gonna make a sticker scrapbook. Yeah, you.
Oh, and just like, this is enough for today.
Have you ever been given the domain and like asked to graph it?
No, but that's a fun idea.
No.
Aiden single-handedly destroyed this entire class.
What did he say?
What was the suggestion?
Said, what if, could I give you just the domain and then you graph it?
Oh, just no.
It wouldn't be that bad. You should know where the asterisks were.
It's just the principle of it.
Right, it's just making your brain go that way. All right, anybody questions? Need an-
Oh, what is the answer?
Wait, it's all there. Hey,
Is this it? Are we done?
how did I graph the points? How did I graph the points? So cotangent of pi over 4 is 1. Cotangent of pi, because it's x over y, is 0.
Which parent would be the best parent?
Because if I'm here,
I like cooking.
oh, I can't read.
Oh,
Yeah. Okay. And then when I get to 3 pi over 4, it's negative 1.
I don't like the
Pi, because it's x over y, is undefined, same with 0. Yeah? Yeah, Ben? Yeah.
I did for the domains, make the pi equal to pi. Is that
Yeah, that's fine.
okay? I could have done negative.
You could have
pi.
done negative pi. I mean, you really could do like negative 72 pi plus or minus pi. That's still correct. Yeah. All right. Those are your 4 parent graphs of today. Now we're going to actually graph them with things happening to them.
They're perfectly fine.
They're fine how they are.
There's 15.
Yeah, I thought that was the last one.
That was just the parent graphs. We gotta like do something with them.
Right.
I think the class is almost over.
Nah, we got time.
Cozy cat.
It's like you're telling me that Cozy can't do this.
Can we put that? Can we just like make a poster of that? Just like put it up. Because that, yes.
We'll just be able to have the same.
Yes.
Oh, great.
Okay.
For a minute. So well.
Guys, what is cosecant related to? Sine. So graph this as if it is negative sine of 2x minus pi plus 2. Fully graph that graph, and then at the very end, we'll turn it into cosecant. So guys, try graphing the sine graph for me, and then stop. And I'll make sure that you understand how to turn it into cosecant. But start with that. So remember, you have to factor out the 2. So what's the period on this one? Pi, good. So I'll give you a minute to graph the sine function, and then I'll put it up here. Yep, do the whole thing. Pretend that I've only asked you to do the sine graph. Again, pause once you have the sine part done, and then I'll make sure you see how to turn it into cosecant. So look up here when you're ready for the sine part. You can do it. How are we doing on the sine graph? Great. You're almost done with it if you get this far. We're really close.
You have to do something crazy with the
We just have to draw the asymptotes in the shape, but that's it. But I'll explain. Yeah. Could be a lot
like a
worse.
spiral asymptote.
No spiral asymptotes.
Is that a thing?
Thank you. Okay. When we did our cosecant graph back here, remember, like from the top of the graph, we had a dot and then the graph went up, right? From the bottom of our sine curve, they shared a point and it went down. And the asymptotes came from where sine was equal to 0. But they came from the midline, right? If the whole graph shifts up or down, it's still those midline points that determine where the asymptotes are. So the one we just graphed, to turn this into cosecant, from the top, they share a point and go up. From the bottom, they share a point and go down. And then those midline points are where the asymptotes are.
Yeah, that's a graph.
Didn't leave enough space. It's just
Mine is very like spring colors.
I mean, my graph is in my problem. It's like
How did I incorporate the what? So right away, when you can kind of see these little red dots, I just did the sine graph flipped. Like I reflected the sine curve, and then I shifted. It's like I took the y values times -1. Because normally sine starts at 0 and then goes up to 1. So I did it down to -1. You see it? It's just reflected over the x.
Oh, and you have
Yeah? Okay. My green. Darker green. What's that?
So how do you get from the sine graph to this point?
So the midline points, the middle ones, those create your asymptotes. And then from the top of the graph, they share a point and go up. From the bottom of the graph, they share a point and go down. You're never going to draw one of those U-shaped parts like right through your sine curve.
Yeah, but like, how do you get
So from the very top of the sine graph, they share a point, right? So the top of the sine curve, they share a point, and then it goes up from there. Bottom, they share a point, and it goes down. And those midline points, that's where you know the asymptotes are. See them?
you just like know looking at the graph, you don't do anything.
Yeah.
Well, that's what we calculated when we did the parent graph, like where it came from. It came from where sine is 0. The reciprocal of that is undefined.
And then wait, how do you
That's where sine is 0. It's just shifted up off of the x-axis, but those midline points are what actually cause sine to be 0, and the reciprocal of 0 is undefined. So always the midline points create your asymptotes. Top you go up, bottom you go down.
I don't understand this.
It is. Flipped and shifted. So you can kind of see, do you see my red dots like there and there? That's sign flipped, the red dots. And then I shifted right to tick marks and up to, but I flipped first. Okay, let's try another one. Oh yeah, we should write domain. Let's write domain at least of this.
You were prepared.
Wait, just related.
Yeah.
Do you do the full like sign thing first, like full sign?
Yep. All right, guys, I'm going to say x cannot equal, I'll say pi over 2 this time. And then plus or minus what? Is it still pi k? It's pi over 2k. Guys, the period changed, so it makes sense that the distance between the asymptotes would change. So that is, I can't like write on the right side of my board. It gets all smushy. So that says pi over 2. I'll rewrite it. Maybe. To remember my page ends sooner.
So like, we can use anything, right, for the file for two, sort of.
The first one, yeah.
First one.
Yep. I mean, anything where there's an asymptote. Yes. Let's be fair.
I'll just use like 27.
All right, let's do, I want to do 2 more graphs. We'll see if we can get through them. But let's do a secant one just to make sure you're getting this idea. 2 secant 1/4 x. Why not? Plus pi.
This takes a while.
So guys, what should you be graphing first? Cosine. So think about graphing 2 cosine and factor out your 1/4. What's going to be in parentheses? X plus 4 pi. So guys, what's the period this time? 8 pi, yeah. Figured you'd like it better. It's not fractions.
It is true.
So do the cosine first, and then guys, see if you can turn it into secant. Don't look till you're ready, guys.
Oh, yeah. Yeah. It's like,
Maybe your gut just knows more than you're giving it credit for.
that's all. Why don't you so that?
I didn't flip it, I shifted by 4 pi, which makes it look like I flipped it.
Oh, so I'm not
You're just doing them right.
Yeah.
Okay, good. Once you've got a graph, see if you can write the domain for me.
The 2 pi over b is
8 pi?
no.
What?
The
Oh.
board.
The period?
Period.
Okay.
There we
So the pink one is the transformations for the cosine, right?
That's the full cosine graph, shifted, all of that stuff. Yeah.
So when you're adding pi, you just add pi, or you add the pi before?
Yeah. I shift by 4 pi.
Oh.
Yeah. Pi over 4 would be tough to graph. And guys, it's completely fine for you to have the cosine graph drawn, like if you're doing this on an assessment, but everybody understands that's not actually part of the secant graph, right? It's just the green that is actually, okay, just want to make sure we're clear on that. Yes. How are we doing on this one? If you can do sine and cosine well, secant and cosecant are not that bad. You're not so strong on sine and cosine. Secant and cosecant are going to be very challenging.
These questions are easier than like the what they're easier than these questions for me.
Oh, okay. Interesting.
I don't know. Makes sense.
All right, guys, what's the domain of this one?
Yeah, I'm not a visual person, so it's just
X such that X is an element of the reals, but X cannot equal what? 2 pi plus or minus 4 pi k. Yeah.
oh, I didn't see
Yeah,
that.
don't forget the pi. All right, guys, we're going to do one more graph. But anybody questions on that? Yeah, wait for a minute. Everybody doing okay with where the asymptotes come from? It's those midline points. Okay. All right, guys, I'm going to scroll down just a little so you can still see the graph, but I'm going to write the next one, okay? Negative infinity, negative 2, 2 to infinity? 8 pi.
Yes.
So it should be back.
Okay.
I don't know.
All right. Have fun.
Yeah.
So I guess it might have been you were.
All right, guys. Last one is a tangent graph. My recommendation on that is don't draw the asymptotes in until you've shifted. Otherwise, you just have asymptotes everywhere and you get confused.
So should we graph this? Just the tangent first, because the other two are swapping.
Oh, yeah, you just graph tangent as tangent. There's nothing, like, weird to do with that. What's the 3 doing out in front of the tangent? Vertical stretch. Yep, stretch those y values by 3. Alright guys, I'm gonna scroll down so you can see this one. And what's the period of tangent? Pi, good. Look once you're ready. Yeah. Well, because I shifted by pi over 2 to the right, the asymptote moved. Remember, that's all going to shift with it. All right, guys, we've got just a couple minutes left here. How do we do on this one? Getting it? Knowing your parent graphs helps. Just tangent. So the asymptotes are now in the same spot as they were for parent graph of cotangent because we shifted. But do you see how the direction of the graph is still tangent to cotangent? Yeah. I know, it's weird. When we get to the writing of the equations and you go backwards, you start to see like, oh yeah, they're all the same, just with different transformations. So.
For the x can not equal, it can be pi too.
Oh yeah. Absolutely.